providing information on comets. We have the advantage up here above the atmosphere. We've been able to see the comet all the way since it started far out from the sun, came in, undergone a lot of large changes, and now is on its way away, and again, changing. What we've tried to do is to not only record with the instruments on the ATM, with the instruments down in the airlock, but also to try to put down on paper what we see by eye. We've done that with sketches, and here the trick is to try to put down the details as accurately as you possibly can and still get across some of the essential points which tend to stand out in your mind. The form, the brightness, the color, and how it changes are all things which have been evident and kind of interesting to us. What I'd like to do now, our first sketch here shows our impression of what it looked like in the early days before perihelion. That's before it got to its closest distance to the sun. And this is just to give you a baseline reference, something which you can judge the following sketches against. And again, this is approximately 10 days or so before perihelion. Faint object initially, and when you first looked at it, about all we could see was just the bright coma, which is a very bright region around the nucleus being the real substance of the comet, the coma being the very bright, intense material around it, which is reflecting a lot of sunlight and in some cases fluorescing or emitting a little of its own as it receives the sunlight. And the last part we'll talk about of the comet itself is the tail, which is a very long and elegant, graceful structure which we see coming out behind it. The color initially was white. We could not distinguish any blues or oranges, reds in it. Now once you got dark adapted, that is once you were able to keep yourself in a dark location so that your eyes could adjust to it, you could see much more of the comet, particularly the tail, which is relatively faint, and you could see it extending back. And it was still relatively short in the days before perihelion. We were judging it was around 1 to 3 degrees or so that we would see it. And since the comet is quite far out, on the order of 1 million miles, 350,000, which is quite a distance, these 1 or 3 degrees would translate into quite a large number. That is, even in the early days, this comet was about 11 times the distance between the Earth and the Moon. I think we all have some sort of a gauge for that now, seeing as it took us 3 days to get to the Moon and 3 days to get back, going at some fairly high velocities. This thing in its infancy was 11 times that length. Now the next time we got a really good look at the comet was right after perihelion, the day following perihelion. And we saw it first when we were outside during an EVA, getting some data on the comet with some of the instruments we took out with us. Now here, it took on quite a different appearance. The length, first of all, was a fair amount longer, 4 to 5 degrees, or around 25 times the distance between the Earth and the Moon. And it was extremely bright. By that I mean we could see it when we were EVA, even with one of our protective visors down, which is something like a very light pair of sunglasses you might wear at home. And it was essentially dividing into 3 different sections. The coma, which we've seen before. The tail, which now was quite a bit wider and quite a bit more intense than we've seen before, most intense right next to the coma. And then there was a spike, which was going straight forward, and it was heading for the sun. It was very close to the sun at this time, and this spike was most pronounced. There was some material which we could see in between here. It was very faint relative to the other features, but we saw it enough times to believe that it really did exist. Now, what I've drawn down here is something to try to give you a little better feel of what the intensities are like across the coma, or across the comet and the coma. First of all, these lines, each one represents a line of equal intensity. By that we mean that, take this circle here in the center, for example, that's the most bright. We pass out to another brighter edge and another one, and so forth. It's like an elevation map you might see of a mountain, for example, where you show the rings of equal altitude. Here we're showing the rings of equal light intensity. They're called isophotons. As we move out into the tail, this is next most intense, and then a region in here. Finally, further out, it fades out, and these eventually will close too further out. And these very faint, this line representing faint emission comes in and is also right around the bottom, where we have that very faint emission between the spike going forward and the tail. On this day, it was really a beautiful sight. We could see it EVA. We came back in and were able to see it out a few of the windows. One, in the structural transition section, the number 3 window, and later on we could see it in the command module as well. On day 364, the following day, the tail had swung around so we could see much more of it. During this period, as it went by perihelion, the tail swung from one side of the comet over to the other side, from right to left, or left to right, depending upon how you're viewing it. We have always drawn it so that the tail is going off to the right for simplicity and for comparison. Here the tail had grown to be quite a length. The total length being around 6 or 7 degrees, which is around 36 times the distance between the Earth and the Moon. And it was still very bright. Now in the color, we could see that it had a slight amount of orange to it. It was detectable. Perhaps it was there the previous day, if we had looked for it and keyed our minds to it. But until something really comes out and hits you, you're reluctant to say that it's there, and that's the way we felt in these observations. But here we could definitely detect a small amount of yellow and orange. The previous day it was primarily orange and white. I'm sorry, it was yellow and white the previous days. We'd never really seen an orange. Spike was still there. The tail had grown in length in terms of its appearance to us, because it now had become, rather than looking at it, if you will, like this pencil almost edge on, it now had swung around so that we could see its full length. And lastly, we have down here our drawing of isophotons, lines of equal light intensity. And again, we see that we have these regions here. They're not quite as abrupt, you know, they're a little bit more rounded here. The previous day they looked fairly abrupt in their cutoff. Here they tend to extend out into more like an ellipse, the edge of one end of an ellipse. Here's the day that we saw it, where it was still close enough to the sun that a lot of the tail still showed up very well, and it was nearly perpendicular to our line of sight. That is, it showed us its full length now. And I might add, the way in which we see this, of course, is the sunlight comes and reflects off of either fine dust particles in here, which we believe that most of this was, and reflected light from those dust particles arrives at us, and we see it. Or if there is any gas in here, it'll cause that gas to emit certain lines, fluoresce, if you will. Light from one energy comes in, and the atoms absorb that light and emit light at a little lower energy, which we can also see. Now here again, the length was around 7 to 8 degrees as we could judge it. In all these observations, we used a pair of binoculars in order to make our closest observations. However, on these days, we could see it very well by eye and see all of these details even without the binoculars. Binoculars just helped us home in a little bit more. So it was 7 or 8 degrees, 42 times the distance between the Earth and the Moon. And it was very bright. Here, this reminded me very much of what I had seen before. I couldn't quite place it initially, but I looked at it several times, and all of a sudden I realized what I had seen before that very closely resembled this was the exhaust plume of a rocket at high altitude. We've seen a lot of them lift off down at the Cape, and what you see down there when it gets to high altitude is first a very intense emission, right close to the tail of the vehicle, very close to the exhaust itself, the nozzle, and then you find that the material tends to billow out and come rapidly back. It billows out because at high altitude the pressure in the exhaust plume is higher than the surrounding pressure, and the gas just tends to come out and billow out very rapidly, and then it gradually decreases in intensity as it goes straight back. That's very much what this reminded me of as I looked at it. The color here again, we did not see the intense orange or fairly bright orange that we have seen before. It tended to drop away. We saw the spike, which was fading now. It was still evident, but it was fading. We saw that as a yellow-white. Again, probably we had to hedge a little on that because it was relatively faint. And when it's faint, it's more difficult to determine its exact color. And then the tail itself, which was yellow and extended back, as I say, quite a distance. We could see the way in which the intensity dropped off here, and again, it was like a series of ellipses with essentially one end all being up here close to the coma. There's something also in here which has started to pick up, and that is a mottled appearance. That is, when you looked at it, you could not always just see a uniform structure fading back into just a fainter and fainter feature. It also appeared mottled, and we'll see that in subsequent days. This is the first day of the year, New Year's Day, and as we observed it, we saw it to be a little bit shorter. Not that the material was not there, but it being a further distance from the sun now, it reflected, had less light to reflect, and therefore appeared to be smaller. Here we saw it only 5 to 6 degrees in length, maybe 31 distance or so, 31 times the distance between the Earth and the Moon, and it was still quite bright, not anywhere near the brightness that we'd seen it in the previous 2 days, especially the first day we were at UVA. We could not tell really whether the spike was there or not. Sometimes we thought we saw it, sometimes we didn't. It was really in mind's eye perhaps a good part of the time. So we put it in there with a question mark. We could see some slight fuzziness, if you will, right next to the coma as the material came off. And then the tail, which went straight back, was yellow-white, or white with a little bit of yellow in it now, and a slightly mottled appearance. And the tail tended to become a little bit smaller in width as you went back and just gradually faded out. That's what this line of series of isophotes is intended to show. We come up on day 2, 4 to 5 degrees. The length around 25 times the distance between the Earth and the Moon, and it was still bright. It was white. We could not see any forward spike. We put a question mark in there, not knowing whether it might show up if we could take a long time exposure with a camera, but we could not see it. And it appeared to billow a little bit here and then move on back with this slightly mottled appearance, pretty much the same as we had seen it the day before, only just a little bit shorter. Most of the yellow color that we had seen previously had disappeared. Day 3. Here again, for some reason, we could see it a little bit longer. Now, there's 2 reasons for this. Either, of course, that it was longer, and in our field of view, that is, it had swung around so it was more perpendicular, although I don't believe that's a cause in looking at the real geometry of the situation. Or, as it got further and further away from the sun, and the air glow, which is right on the horizon as the sun sets, we were able to get better dark adapted. Our eyes could adjust better as the comet was further away from the sun, and I believe this allowed us to see more of the features. So when I give a distance here of 5 or 6 degrees, even though the previous day was only 4 or 5, what this means is that we were better able to see it, not necessarily that it had grown in length. This distance here would be like 31 times the distance between the Earth and the Moon. Quite an appreciable distance. It's quite a large-scale phenomena. We really can't appreciate that until we start looking at some of these numbers. Now it was white. The coma and the tail was just plain white. Still this somewhat billowing appearance, a little bit of this material up close to the head coming off, and the isophotes down here also depict that. Day 4. Again, it was quite long, 6 to 7 degrees, and I believe this is because we could get really well dark adapted, and we could see the very faint features of the tail go out quite far. It was white up around the coma. It was medium intensity or so in emission, or not in emission, but in light intensity, and around 36 times the distance between the Earth and the Moon in terms of our observable length. Now, when I give you these intensities, I'm hedging a little bit by giving you words like bright or faint or medium intensity, very bright. I'm doing that purposely because we had no way on board to make accurate quantitative measurements of the intensity, so I'm just trying to give you a feel on a relative scale of what it appeared to us. The color of the tail, now as we looked especially further back, and we get very dark adapted, seemed to have a small amount of violet to it. It was white, but it also was had a little darkness in it, which appeared to us to be a violet in nature. Down here we see the isophotes again, and we denoted that there was a star here very close to it. For this drawing up here, it was around 2 or 3 degrees back and a couple degrees down. It's a star Dobby. Now here is yesterday's, how it appeared to us. And the tail now had become a little shorter in length, visible to us anyways. 4 to 5 degrees, 25 distance between the Earth and the Moon, and it was faint. Fairly difficult to see. There's Jupiter and Saturn are 2 planets which are out close by, and if you get those in the field of view of your binoculars, it's very difficult to see the faint features of the comet because your eye tends to adjust to the much brighter features of the two planets. It appeared white up around the coma appearing much smaller to us now. It has shrunk in the days as we moved on. And now we see back here again this white of violet, and there was no longer any question. We did see violet in the tail. Whether this is because we were really looking through the tail at a slight amount of air glow, which I doubt, whether there's actually violet emission coming from the tail, we can't be sure. If it was this violet or blue, it could tell us that we were looking at part of a gas tail as well. Although it did coincide quite well with the dust tail, and we don't want to try to interpret that right now. We'll just give you our observations. So we've seen in these days, from our early observations on through day 5, day 6, which is in preparation now, we've seen the form change quite appreciably. We've seen the spike come and disappear. We've seen the size grow quite appreciably, even when it was very close to the sun. We've seen it shrunk down a little bit, and then we've seen it grow again as our eyes become back dark adapted and see the tail. We've seen the color go from a white to a yellow to an orange, back towards a white, and finally show up with a little bit of violet in the tail. And its brightness changed quite drastically from something which was very dim, maybe an order of magnitude star of 3 or 4, on up to something which was maybe a minus 1 or 2 on the scale, and then on back down towards the lower intensities. And we've seen its tail become quite long, up to 40, perhaps 50 times the distance between the Earth and the Moon. So it's quite a large structure out there. Well, we've enjoyed looking at it. We hope these have been useful to the people who are studying comets. We'll certainly be interested in comparing these when we get back. And we hope they've been interesting to people who are not professionals in the field or studying comets, but just with a curiosity about what is one of these structures like. And we hope you've been able to appreciate it a little bit in the same way we have.